What's the fluid boiling point viscosity recommended, and what FOMO numbers you recommend? So there is a work stream in OCP, which in Open Compute project, and Open Compute is great for many. There are many community projects which are actually driven by the, let's say, engaged community, and they make a good progress. But sometimes, well, we steer away from the actual purpose, or let's say the goal, which would be the adaptation of the technology, and we start to make things more complex that we actually need to. And I guess it's that when we are thinking about the immersion coolant. So there are some parameters which immersion coolant should conform to or should have, and there are in the OCP there is something which is called figure of merits, FOM numbers. You don't care about the FOM numbers, figure of merits numbers. It doesn't make any sense. It doesn't, let's say, give you any value. And we actually try to structure or understand the cooling medium based on the composition of the cooling medium, based on whether it's group 3, group 4 cooling medium. We use only poly, alpha, olefin, PO-based coolants, nothing more. We don't want to have less capable, less stable coolant like group 3 coolant, GTL coolants. We don't want that. We would like to have PO based coolant, and those coolants have different components, let's say different compositions, but the coolant which we recommend and the type of the most important factors are the low viscosity. Low viscosity is pretty important in that sense that the low viscosity means that the fluid better penetrates, better flows, and we also need smaller pumps to circulate the fluid. So smaller pumps, less noisy, less power hungry pumps in the operation. And sometimes the choice is that we need to actually fit a very large pump into the immersion tank, and then that's why those tanks which you see on the market, they are so big, so enormous, they don't really fit anywhere. So we like to have low viscosity coolant, and the viscosity at the 40 to 60 degrees Celsius temperature, so the inlet and the return temperature which you can expect, would be at the level of 4.6 to 4.3 centistokes. And that's where the fluid becomes kind of water-like. It resembles water in terms of how it flows, how it behaves. It also allows us to better control the flow inside of the tank. The pour point may be important. The pour point is important if you're operating in the low temperature locations, in edge applications. The low pour point means that the fluid will not basically start getting slushy when you'll be still able to operate with that coolant in the different edge applications, different locations. The flash point, as we discussed previously, 150, 160 degrees Celsius, that's the flash point. So only, let's say, and the fire point would be at the level of 170 and 80. So that's pretty safe coolant to operate. It's not flammable, it's not combustible, is the right flash point which you have. Sulfur content, very important. Sulfur means corrosion. So corrosion of electronic components. So if you have 20 ppm, so that's something what you are looking for. Virtually no sulfur means that's the right coolant which you want to operate. Viscosity, breakdown strength. Well, we can start from 20 something, but what we expect and what we would suggest would be the level of 50 to 60, and that breakdown voltage is, I guess, important because it degrades over time. When you start getting a slightly higher water content because it gets some humidity from the air, then the breakdown strength is lower. So I guess the 50 to 60 would be reasonable to expect from, let's say, from the coolant. And obviously specific heat between 2.2, 2.3, I guess it's something what we can expect. Thermal conductivity, no solubility in water, so basically it must be hydroscopic. So these are the most important parameters which define the heat transfer capacity, the daily operations, the build of the tank, and so on and so forth, and the safety of use. Don't even consider those figure of merit numbers, doesn't make any sense. Just, let's say, think about that one as the fluid in the way that it should be. It should have no aromatics, should not have any, let's say, aroma. It should be low viscosity fluid. It should be based on polyalpha olefins. Yeah, and that's most important parameters when choosing dielectric coolant.